Let's take a look. Okay, so we start off with a situation here. We're looking at graphs, and we're just reading graphs. In a sense, remember, graphs are a table of x values horizontal versus y values vertical, or we consider them inputs and outputs, right? Where input is the x value and y is the output, our result of our x interaction. We've been looking at these as functions and in different ways, different terminology. So we're going to see a relationship. We also looked at them as ordered pairs. It's like, for instance, this point here would be considered x is 0, y is 7. While this point here looks like it's going to be 3.5 for my x and y is 0. Now, these points are just values on the graph, values that I represent on the graph. If I pick a point over here, let's say 7, 7, is this on the graph? No, 7, 7 has nothing to do with this graph. There is no relationship for 7, 7. So all the relationships are stuck on this graph. Like 1 is 5, 2 is 3, 3 is 1, and 3.5 apparently looks like 0. Okay, so all these values are values representing the function and the situation. Now what's the situation? Let's go ahead and read. The graph shows how the number of glasses that Bridget has left is related to the number of tables that she has set. So glasses, I was thinking about maybe her eyeglasses, but when she said table, I'm thinking, oh, these are like water glasses or wine glasses, okay? And Bridget has to set this table, so maybe she works at a restaurant or a convention center, or maybe this is someone's quince, and they're setting up for the party. So Bridget has to set up glasses based on number of tables she has set. So if she has 0 tables set, she has 7 glasses remaining. If she has, let's see, number of tables she has set. Okay, if she set 1 table, that means she used some glasses and she has 5 glasses left. She set 2 tables, that means she used up more of her clean glasses and she has 3 glasses left. If she sets up 3 tables, she only has 1 glass left. Okay, so now that we understand the situation in a way, how many tables does Bridget need to set in order to have 3 glasses left? So here's the big key thing here. They want to know, use a highlighter. They want to know how many tables when Bridget has 3 glasses left. So since we have glasses here, we know the number 3, right? So at number 3, 3 glasses, she has 2 tables left. Let me do that one more time. It's not that she has 3 tables, right? She has 3 glasses. So we want to make sure we start off on the right part of the graph. If you give me glasses, we're over here glasses. That's glasses. And we're at 3. That means how many tables does she have left? That's just 2. So one of the things about this IXL training is that it's getting you to read the question, making sure you start off on the right part of the graph so you can find its matching pair, its ordered pair, you could say. So let's go ahead and try to see if that answer was true. We said there's 2 tables, again, at the value 3. 3 glasses. Here's glasses. We have 2 tables left. Easy peasy. Now, this question looks, they changed the format of it. Let's go take a look. Okay. So this graph shows the total number of hair bands Vivian owns in relation to the amount of money she spends on additional hair bands. Okay, reframing that. She has hair bands, and if she spends more money, she'll have more hair bands. Okay, so give yourself some time to reinterpret this sometimes. So I see number of hair bands Vivian owns is related to the amount of money she spends on it. So here's how much she spends, and this is how many hair bands she has. And the more money she spends, guess what? The more hair bands she has. That seems to make sense. So let's go ahead and answer the question. How much money does Vivian need to spend on new hair bands in order to own a total of 90 hair bands? So we're talking about 9 over here, $9. 90 is up here. So how much would she have to spend? She would have to spend $5. So this could be a bank chart, right? If you're working at a bank, you're making over $100,000 a year, and they ask you to come up with a chart to talk about their profits. This could be a table related to the profits. If we have 1 million, 2 million, 3 million, this could be 10,000, 20,000, 30,000, and this could be marketing, saying, hey, if I spend this much money, this is how many new customers we're expected to make. Okay? Or this could be investments in computers, and this is our productivity. This could be something like cafeteria workers talking about if I spend $1, $2, $3 on hygiene or on extra on quality foods, people would like it more. Satisfaction ratings would go up. So we can change these graphs to say whatever we want. There's actually a slogan about statistics. You know what statistics are? Like numbers that represent populations or groups. Like 4 out of 5 doctors recommend Colgate toothpaste, or 7 out of 10 people like Pepsi versus Coke, like stats. There's actually a slogan that statistics lie, and liars use statistics. Pretty interesting. So how much money does Vivian need to spend on her new hairband? 790. We said that was going to be $5. Oh, thank you. Wow, fast. Good job. Thank you. Do appreciate that. Perfect. That was great. Okay, so this could be actually fairly easy, but it could also be hard if you don't spend time reading it. And part of math is not just doing the problem, but understanding the situation. Because when we first start in algebra, we are given the answers. We are given all the situation. We're given all these like variables. But as you get better at this, you start creating the variables. You can start creating the situation. You can use algebra to solve for things in your life. And that's kind of like the end goal for you guys to actually apply this. And people will say, Mr. Ko, when will I ever use this in my life? And it's true. If you're just going to go to the market and just throw stuff on the register and have them tell you how much you owe, yeah, you'll never need this. But if you really want to go into engineering, you want to go into medicine, nurses use algebra all the time. When it comes to like dosing, doctors, pharmacists have to give you a prescription based on you as a person. If I give a blue pill to you, as let's say you weigh 100 pounds and you're female, versus you weigh 300 pounds and you're obese male, that one blue pill isn't going to do the same thing. And algebra helps you figure out how much dosage you should give. So a lot of things take this algebra mind concept into play. Okay, so let's just do this last one and we'll see. Oh, you know what? I'm going to jump up one more. If you guys were reading that, good job. Let's jump to the higher one. Just, again, very similar to other ones. Okay. Okay, this graph shows how the total distance remaining to drive depends on the number of miles Kate has already driven. Okay, so I gotta tell you this. Like, you guys might not like word problems. Mr. Ko was never good at them. I remember in 3rd and 4th grade, them still giving us word problems about the stupid train leaving LA. Hell if I know. But it's not about if you know right away. You have to give yourself time to work it out. Honestly, that's what all this stuff is. When you guys get a new cell phone, right? Okay, cell phone and math are totally different, right? Because you want your cell phone. But don't you have to learn the new features of your new cell phone and you have to give yourself time? How many guys have had to teach your parents how to use a new cell phone? You guys want to pull your hair out, right? What's this Touch ID? Why do I want to touch it? Oh, where's my Touch ID? I just look at my phone. You guys ever try to teach your parents how to use email? Gosh. Well, the reason why I bring this up is because all this stuff, there's a learning curve, right? And you have to give yourself time to get used to it. So this graph, let's go back to it. This graph shows the total distance, okay? Remaining, here's my remaining versus how much I've driven, which makes sense, right? If I drove 0 miles, I have 7 miles remaining. If I drove 1 mile, I have 6 miles remaining. If I drove 2 miles, I have 5 miles remaining, because apparently the trip is 7 miles. So after 2.5 miles, I should have about, looks like 4.5 miles left, right? And that's all based on the chart. And the cool thing about the graph, you don't do any math. The math is already all done here, which is the great thing about charts. It breaks down values so that you don't have to overthink. Okay. All right, so let's go ahead and move on to our next IXL. And that's 15, interpreting functions using everyday language. Now this is a or B one. I mean, like there's either the first or the second one, and they're written in a way that can be slightly confusing because we're not used to it. Okay, and once we get used to it, we're okay. Anyone here speak Spanish? And you speak Spanish, right? But when you went to Mexico to visit family, let's say, or um, maybe Ecuador or in El Salvador, they speak Spanish, right? Okay, I have some salvies here. Um, but like even though you speak Spanish, you still have to get used to it, right? Like if I go to when I go to Taiwan, I learned to speak Chinese, but I still have to get used to it. It still feels awkward just speaking it. Okay, let me go ahead and take a screenshot. Let's go ahead and take a look at this. Getting used to things. Classic Exteriors is a house paint company. It takes the painter's FX hours, so this is my function here, to put in X coats of paint on a house. So when you paint a house, you want to put more than one coat. It makes it last longer. It makes the paint thicker to resist the elements, the sun, the wind, the rain, okay? So the old color of the house doesn't show through. That's usually what we call the primer first. Okay, so again, understand the situation. F of X is a number of hours. X is a number of coats. So here is our defining function. If I plug in 2 coats, I need, what does F give you? F gives you hours. Okay, so F, this is my hours. How do I know how many hours I need to work? You need to tell me how many coats you put in. Okay, and it says if I put in 2 coats, it's going to take me overall more than 3 hours. Okay, how did I know that was hours and not coats? Remember, f of x is my machine, it's my output. So if I input the number of coats, it outputs the number of hours. So this is the number of hours here. So let's read the 2 possible prompts. Well, I'll give you guys a couple of seconds to read them yourself. Okay, go ahead, read them yourself and make a decision. Don't call it out loud. But I want you guys to get ready to type it in the chat, but don't hit enter. So if you think the answer is the first one, write 1. If you think the answer is the second prompt, hit 2. And you're going to type that in the chat, but not yet. Don't do it yet. You're going to do it all at the same time. And you're going to do it really fast. Okay, so go ahead and read the prompt. It takes the painters more than 3 hours to put on 2 coats of paint. Or is it takes more than 3 painters to put 2 coats of paint on the house? Which one do you think would be more precise when we're talking about the representation of this function here? Give you guys another 10 seconds to make a decision. Once you make a decision, go ahead and type number 1 or 2 in the chat. Okay, you guys go ahead and type. Great job. You guys all read it pretty fairly easily, right? Because I talked it out too. So if I plug in 2 coats, the function tells me, hey, it's going to take me more than 3 hours. Good job. And that's really what this is. Understanding how to use functions in these word problems. And In the real life world, when you talk to a guy about painting your house, he looks at your house, he looks at how big it is, he says, how many coats do you want? What type of paint do you want? He thinks in his brain, how many workers do I have? So, like in actuality, like this guy, this painter, this owner, this guy who's going to give you a quote, in his f of x brain, he's thinking, okay, you tell me how many coats, I'm telling you how many workers I have, how many, how much paint I need, and he's throwing these values in his own head to come up with a function and say, you know what, this is going to cost us 4 days, right? You guys are kind of young, but maybe you've been part of that estimate where your parents are trying to make something or build something, and you're telling them all these things you want to do. And in their brain, they're thinking, okay, what do I need? How do I calculate this? Because there's a function going on, okay? Which is kind of cool. We all do functions in our head. We all do math. If not, we'd be poor. Fantastic. Okay, let's go ahead and read the second one. In order to raise money for a school dance, students in leadership class are collecting cans to recycle. Okay. When they recycle X bags of cans, they make F of X dollars to put toward the dance. So, what does F of 20 tell you? So, remember, the X is cans, F is money. Okay, so think about it. Let's look at go ahead and read the 2 prompts and see, do any of these make sense? Could you have come up with a prompt yourself, right, without reading their suggestion? That's a little harder, right? Okay, so if I say I'm plugging in 20 cans gives you money of $60. Okay, so it's not student makes $20 when they plug in 60 bags. I'm not recycling 60 bags. I'm recycling 20, so I get 60. Okay, so answer is going to be the first one. Again, you're just going to practice these out. The idea is that we're working on easy elements of word problems and see, hey, there is a relationship. And this will go on for a little bit. And you'll get up to 90 pretty quickly, okay? The last one is, I would say, the hardest IXL because it's one of the newer concepts to us. And that's rates of change. Now, rates of change is a math term that refers to, it's almost like a comparison, something over something. So let me go ahead and give you guys an idea of rates of change here. And rates of change is something that you see in algebra, geometry, algebra 2, pre-calculus, and calculus. Okay, rates of change. And here is something that you should be thinking about when you hear the word rate. A rate is always something for something. And that's represented by a division sign. Okay, or the word per. A lot of different ways of representing this. The example is, can anyone actually know it? Give me an example of the word rate. Have you heard the word rate in anything in real life? Not a rating, like a rate. Anyone hear the word rate before? In what context? No? You've never heard of the word rate? Maybe you're shy. If you heard of a context, you can just throw out a word in the chat. In anything. Where have you heard the word rate? It's actually all around you. Have you heard of something? Time? Yeah, it's actually, time is important in rate. Almost all the rates that we talk about are based on time. An example is a parking meter. You ever have your parents ever parked a car, they had to pay a meter? Isn't it something like 3 minutes? Whoops, like 3 minutes per quarter or something? Or 12 minutes per dollar? There's something called rates when it comes to speed. Miles per hour. I was driving at 100 miles per hour. That is a rate. In front of the schools, you have to drive 25 miles per hour. What else is there rates? Rent is a rate. I have to pay $1,000 per month. It's $1,000 per month. How about when you want to lease a car? I pay $491 per month. And that's money over month. That's a rate. How fast do you run? I run at 2 miles per hour. Yeah. Okay. Some of you guys do like a 7-minute mile or a 6-minute mile. That means you guys run at 10 miles per hour. Wow. And when you bike, do I have bikers out here? You guys bike at something like 14 to 20 miles per hour. When you're blazing, you're like 20 miles per hour. Okay. So these are all the idea of rates. And if you notice, they are always something for something. They're comparing something for something. And for us, rates will be rise over run. And that's our major algebra rate. And this is what we call the fancy word slope. How much is this graph changing? Look at this graph. How much is the graph changing from point A to point B? If this was your bank account, would you be making money or losing money from point A to point B? If this was your grade, would you have a higher grade or low grade from A to B? If this was your health, right, from A to B, would you be healthier or less healthier? And all these could be represented by this graph. And in algebra, we say the rise over the run. That is the ratio. That is the rate that the line is growing or, I would say, increasing or decreasing. Okay. Now, the way we do this on tables, let's go ahead and take a look at our problem here. They're going to ask us, what is the rate? So figure out how many vacation days he had left to use. Dylan looked over his old calendar to figure out how many days of vacation he had taken each year. So when you guys have a job, you make an idea of, hey, when do I want to take a vacation? Right now you're in school. You guys are stuck with the vacation days that the school district gives you. But when you guys have your own job, you can actually make out your own vacation days and how many you take. If you have a fancy job, let me tell you this. Teachers get 10 sick days. Okay. Some of your parents get 10 sick days plus they get another 10 vacation days. And depending on the job, usually the better the job, the more vacation days. The example is my wife got 20 vacation days a year. So that means 20 vacation days. That means how many days are in a work week? 5 days. So she had 5, 5, 5, 5. She had 4 weeks off a year. And that was what they call a paid vacation. She doesn't go to work and they still pay her her full rate. So my wife, before in her old job, she could take a whole month off and still get paid for every day. Do you guys wish you could take a whole month off of school and still have an A? No one likes that idea? That'd be crazy, right? Some of your parents, when they take you on vacation or maybe a trip to Vegas, they're not working. And you might have asked them, You're not working. Why not? Dad, go work. Mom, go work. Right? That would be amazing. Right? I had friends with 6 weeks vacation time. That's crazy. Right? Because their job really allowed for that. Um, so you might have asked your parents, hey, you're not working. How are you making money? How are we going to keep our house? And it's because they have vacation time. Okay? The better the job, the more vacation time. Well, you usually earn it. Teachers, all we get are sick time, but we get vacation time because whenever you're not at school, I'm not at school. Shoot, this is being recorded. Okay, so he created a table here, Dylan, to figure out how many vacation times overall. So according to the table, what was the rate of change between 2018 and 2019? So he wasn't asking for the full chart. He only wants 2018 and 2019. So this is the rate that we're going to look at. They told us vacation days per year. So please take a look at how I mark this. Vacation days per year. So we want to write vacation days on top versus years. And this is the fraction we're going to aim for. So vacation days are here and years are here. So all you do to find out rate is you subtract over 2019 minus 2018. You subtract the values to figure out how much is the difference so we can find out what that rate is. So 17 minus 11 is 6, and 2019 minus 2018 is 1. So he has vacation days per year. So he has 6 vacation days per year that changed between 2018 and 19. I want you guys to look here from 2018 to 2019. Okay, how many days was the difference? How much changed? What was the rate of change? The rate of change was 6 days for every 1 year. Now, how does that work practically? Well, I want you guys to think of this as a different way. Imagine if I told you about how much you would make at working at Old Navy. What if I told you make $13 per hour? Okay, and this is a rate of change, $13 per hour. Another way of writing it. So if you work 2 hours, you would make $26. But what if you work 3 hours? Isn't the rate of change $13 for every hour you work? That means you have $29. How about if you work 4 hours? Well, again, another hour means another $13. So that's your rate of change. Well, this is 39. That's $52. Wow, you can be making a lot of money working at Old Navy. No joke. This is one of my students. He works there. That's how I was thinking about it. Okay, so knowing what rates of change are and how we can use them, super important, super helpful. Now, we said, what are his vacation days per year between 2018 and 2019? They are, we said, 6 vacation days per year between 2018 and 2019. Let's look at another prompt. Ms. Middleton told students how many rounds to expect in a spelling bee based on previous years. And spelling bees happen remember they go round and round. You know what a spelling bee is, right? You spell the word Wednesday, and if you get it wrong, you get kicked out. But if kids get it right, they keep going. And this could go on forever as long as those kids keep getting things right. So in 2014, there were 11 rounds. In 2015, there were 6 rounds, so on and so forth. But we don't care about the whole table. Please, we don't care about the whole world. I don't care about your whole life. I just care about, let's look at the dates. According to the table, what is the rate of change between 2017 and 2018? 2017 and 2018 only. So can you guys tell me what was the change between 2017 and 2018? Do I have to do the math? Hopefully not. That's 4 rounds per year. Right? And that's what they wanted, 4 rounds per year. Or you could count 5 to 9 is 4 over 1 year. Now, we're going to see an example here as it's not just 1 year anymore. 4 rounds per year. Now, if we look at this one, let's jump down to the years that we see. And the years now are between 2016 and 2019. 2016 and 2019. So let's find those on the chart. I see 2016 and 2019. If you want to read, every year Princeton has a citywide relay and reports the winning times. So in 2016 was 34. 2019, oh my gosh, 46. That's a big change. Okay. Now, according to the table, what is the rate of change in minutes per year? So minutes on top, years on bottom. When you say per, remember, the per part is on the bottom. So what was the change between 2019 and 2018? 46 minus 34 over, keeping the same order, 2019 minus 2016, keeping that same order. That's going to be 12 over 3. Well, can we reduce 12 over 3? 12 divided. Thank you very much. That's 4. Great job. So that's complete this correct all the way through. This is 4 minutes per year. Now, I want to show you guys that how does this really work out? This is what we call the average rate of change, meaning, sure, it's not going to be 4 every single year, but over 3 years, it's 4 minutes per year. Let me show you. From 34, after the next year, this should have been 38. Okay, from 38 after next year should have been 42, and 42 after the next year is 46. And this is what we call the average rate of change. So over this long period, I get it. It wasn't exactly 4 every year, right? That's not 4, that's not 4. But over the full length from 2016 to 2019, there was a steady growth of 4 per year. Get it? It's 4 per year. And if you guys listen to climate change, this is how they speak. It's not that next year was exactly 1 degree hotter. It might have been 1 degree lower, but over 100 years, this is what the change has been. Okay? So hopefully you can see I chose 2016, 2019, and I subtracted those from each other to find the rate of change. And I divided it to find the average rate of change. Okay, we'll do one more, and then we'll call it a day. We said it was 4 minutes per year. Okay, now let's do this. Let's jump one more. Okay, so a little bigger numbers, about the same. A dog enthusiast records the weight of winning dogs in a recent show. In recent dog shows. Okay, so here's the numbers. So now according to the table, which are the rate of change between 2013 and 2016? What the rate of change? Okay, so we went from 50 dogs, or 50 pounds, well, kilograms, I'm sorry. Gosh, the rest of the world. So 50 kilograms and 76. So that's the rate of change. So you always write the bigger number. Oh, actually, you know what? You pick an order. I picked this minus this, later minus earlier. 50 over 2016 minus 2013. That gives me 26 over 3. 26? Yeah, 26. And over 3 years. So this is a decimal for us. And we see round to nearest 10. So if we 20, 3 goes into 26 8 times, remainder 2. So this is approximately 8.66, because 2/3 is 0.66. And then nearest 10th, rounding up, 8.7. And 8.7 is just a number, but in this prompt, it is 8.7 kilograms, let's say kg per year. So if I add 8.7, then 8.7 again, then 8.7 again, it'll get us to 76. Okay. Let's see how we did here. 8.6 rounded to 8.7. Come on. Yeah. All right. So these are the examples of, or IXL. I really wanted to work them out just to give you guys just some practical examples. So these wouldn't be too difficult. Some of you guys actually might be done right now. But okay, so get to it. Besides that, we're done for today. Okay.